Parts of the cathode ray oscilloscope. The cathode ray oscilloscope has the following parts: the electron gun, a system of deflecting plates, an evacuated strong glass tube, and a fluorescent screen at one end of the glass envelope. Place the mouse over the different labeled parts to get an explanation of what they are and their functions. Working of the CRO. The animation below shows the working of the CRO. Click on its play button and make your observations. Explanation. When the cathode grid potential is made more negative, it repels electrons, and only those with very high kinetic energy will manage to proceed. Therefore, the grid determines the intensity of cathode rays leaving the cathode. The anode is used to attract the cathode rays from the cathode, hence giving them more kinetic energy. Explanation. When the cathode grid potential is made more negative, television tubes. A TV consists of a short electron gun, 2 pairs of coils, and a fluorescent screen. Discussion. The black and white television works in a similar way as the CRO, except that the deflection is by magnetic fields produced by currents in coils. It has 2 time bases, one connected to the Y plates and the other to the X plates, such that they sweep the dot vertically and horizontally, respectively. The deflection set the electron beam to move repeatedly across and down the screen, forming a complete picture consisting of adjacent lines in about 1/25 seconds. The scan produces slightly different pictures, enabling movement to be portrayed in the same way as in a film, with rapid succession of still images, giving an impression of continuous movement. A color television works on the same basic principle, but uses 3 electron guns, one for each primary color: red, blue, and green. Though the electron beams are not colored themselves, each affects only one set of red, blue, and green phosphors on the screen, and the amalgamation of the 3 colored images produces a full color picture. In color televisions, the incoming signal is processed by a decoder. The beams pass through a metal shadow mask with thousands of holes arranged symmetrically so that the beam from each of the 3 guns only strikes those phosphor dots of appropriate color. Uses of the cathode ray oscilloscope. The cathode ray oscilloscope can be used to display any electrical signal whose variation can be put in form of a voltage. Some of its uses include measurement of voltage, measurement of frequency, measurement of small intervals of time, among others. The uses stated here are captured in the animations which follow. Measurement of DC voltage. Direct current can be measured using the CRO as shown in the following animation. Click on the play button and observe how this is done. Measurement of AC voltage. Click on the play button and observe how this measurement is done. Observations. When connected, a straight vertical line is displayed on the screen. Explanation. The length of the displayed line shows the peak, to peak voltage of AC voltage. Measurement of frequency. A signal of a known frequency, like the heartbeat of a person or some musical sound, can be fed to the input terminals of the oscilloscope. Using the time base, the settings are adjusted to obtain waveforms that appear stationary. Frequency of the signal is equal to that of the electron beam oscillating between X plates. The time base is read off from the scale division, and the mean is determined by counting the number of full waves in a certain distance on the x-axis. Mean wavelength is equal to the distance measured on the screen divided by the number of waves displayed. Knowing the wavelength and the time base, the mean period t for a full wave is found. Frequency f equals to 1 divided by t. Click on the play button on the animation below to see how frequency can be measured using a CRO. Observation. A sinusoidal wave is displayed on the screen. Measurement of small intervals of time. If a drum is struck twice consecutively and sound picked by a microphone and connected to a CRO, the microphone will convert sound energy into electrical pulses. When these pulses are fed to the input terminals of the oscilloscope and the time base put on, a signal will be displayed on the screen. If time base of the CRO and the distance between the signals of the pulse is known, the time intervals between them can be calculated.